Welcome to all. Class number 57, Simply Support Beams. We are continuing UDL with the point loads. More and more example. Now onwards, for at least for 4 or 5 classes, same title will be there. I won't put a subdivision number. Just to go through the classes. See, question written here. There will be some changes. See, purpose of doing multiple problems is not to see that number of classes increases. Purpose is to see that each and every concept is clear. That is the main purpose. Simply supported beam of span 10 meter, written here 10 meter span, loaded by UDL of intensity 12 kN per meter, 6 meter long, starting from left end. So from left end goes for 6 meter. Earlier we had done this question, but at that time there was only UDL. Once on the left side, then on the right side, then central portion, then with the point, you full UDL with the point load, then central UDL portion with the point load. Now more questions. Then 60 kilonewton point load at 3 meter from left end. 30 kilonewton point load at 6 meter from left end. 6 meter from left end means exactly the point where UDL is ending. Then last one. How much? 90 kN at 2 meter from right end. So when this is 10 meter, this is 6, this will be 4 meter, 2 meter here. Later, remember, I will write this gap 2 meter and this is 6 and 3. This also will be 3. I will give some names A, B, C, D, E, etc. First, calculation of support reactions. Take moment about A. These all is mechanical. I won't explain about these things. I told you earlier only. This is your problem. Now you have tried these things. Take moment about A. Minus V clockwise positive. Now I will not tell. Sigma M, sigma V, equilibrium conditions, shear force bending and section forces. It has been told plenty of times. So those who are serious in learning, they will follow. Minus VB into 10 plus 60 into 3 plus 30 into 6 plus 90 into, this is 10, this is 2, therefore 8 plus 12 into 6 is the total UDL into half of 6 equal to 0. You get VB, sigma V 0. I think I need not explain. By this time, you know how to get it. Plus VA, plus VB, minus 60, minus 30, minus 90, minus 12 into 6 equal to 0. You get the value of VA. Now we are ready for SFD and BMD. Okay. Now, one small information for you. I am rubbing the full question now. Because next phase, I will put the beam with reactions here, SF calculation and BM calculation. Now, I will tell now only in the class number 58, I will solve the same question. Some are bound to ask, why? Why same question? There will be some reason. Okay. Here what will happen is, your SFD will come this way, then down, it will come here, and it will cross the baseline somewhere here. Before that point load, it will cross the baseline. So, when you go for BM calculation, little work, extra work is there. So this question is more important. Then class 58, I will tell you at that time. I already told in class 57. Go through it again. Same question. I will not give words. I will directly give sketch. Only change is this 30 kilonewton load I will increase. Maybe 65, 70, 75, 80 to that range. Because then what will happen is, your SFD will come, it will cross the baseline here. Means the shape of the BMD and SFD will slightly change just to understand thoroughly. So I will tell now itself, class number 58, question I am explaining now only. This particular load, 30 kilonewton load is going to change. All remaining, this point load, this UDL, I am maintaining same. That will show you as this load increases, what will happen is the point of maximum bending moment will come near and near and near to it. Now, suppose this comes some distance here. As I increase the load, the point of maximum BM or where shear force is 0 will go more and more that side. Finally, it will come exactly to that point. Then it will remain there only. If you increase the load further, it will remain there only. So that's why class 57 and class 58, if you simultaneously study, you can learn lot of things. Okay. Now, I'll remove everything and make ready for SFD BMD. Now, beam is ready. I wrote everything here neatly. SFD BMD space I have left. Shear force calculation. I told earlier, I will stop this shear force calculation after some time if it is same type. Yes, it is same as earlier. But still I thought, one more chance. Okay, give it. Shear force at A. I told slightly come inside. Look this side. Plus 122.4 kN. At C, you have to write a note. There is point load, 2 calculations. Shear force at C, just to left of C. 122.4 previous value, after A up to C, downward load of 12 kN per meter for 3. Subtract, you get the shear force. Come to just to right. Whatever you got just to left, subtract 60, you get shear force just to right. Same way, come to D. Again point load is there. Once just to left, then just to right. Just to left answer. Previous answer minus 12 kN per meter for another 3 meter. Okay. Just to right. Whatever you got there, minus 30. Then E. Again just to left, just to right. Just to left. The previous value, that's all. Just to right. Minus 39.6, minus 90. We get the answer. Lastly at B, slightly inside, the previous value itself is shear force. I explained this so thoroughly earlier. Now, if I explain all these things again and again repeatedly, it will be never-ending process. Sometimes somebody will tell, no, we have not gone through other earlier classes. We are coming now only. I will tell, go to earlier classes. If you are learning, learn full. Don't come in between. Anywhere I tell, in my entire education, I always tell, start from beginning, study up to end. Intermediate entry is not allowed in my class. If you are highly intelligent, if you are following, that is your problem. Sometimes some will tell, no, I will understand. Good, understand. But do not put the blame on me. This is not told, this is not explained. What this is not explained? How much I explained earlier? Start from class number 1. See there, how much information given. Okay, now last. Sorry for being little harsh. Now, one note. Go back and draw shear force diagram. I told you, you need not see any of this calculation for shear force diagram. Take your calculator and start. Without seeing there, you don't have to see anything there. See, go up by 122.4. I'll enter here, 122.4. Just 1 minute. I'll check the camera. I do not want to go out of the camera. Okay, no problem. Sometimes it happens. Slight moving, value will not be visible. Okay, then from here to here, come down by 12 into 3. So 122.4 minus 12 into 3 will give 86.4. See, only 36 drop, not too much drop. Oh, how much? 86.4. Come down by 60. Severe drop now compared earlier. So remaining will be 26.4. But in the calculator, you should get it. Minus 60. How much? 60. And then from here to here, again come down by 12 into 3. Minus 12 into 3. Minus 9.6. See, 26.4 here. Very small. Minus some, how much? 9.6 means further lesser. See, I will slightly make more here so that, okay, reasonably okay. The value is 9.6. Okay, I'll enter 9.6 later. Come down by 30, minus 30, minus 39.6. From here to here, no load, go parallel to baseline. Down by 90, minus 129.6. This is 122.4, 129.6. No load up to here, go back by 129.6 over. Plus, minus, okay. Shear port diagram, that value is 9.6. I will write here now, it is 9.6. Okay. Now you can do one thing, check all the values. SFD over. Now, again note, see what I am dictating, if you are serious, you should write it. Every time write it. By writing repeatedly, same thing every time, you are learning, you are not losing. Observe SFD. Yes, SFC observe. Is SFD crossing the baseline at a point? Yes, you will tell. It is crossing baseline somewhere here. Yes. Is it a known or unknown point? No, it is not known. I am asking question, I am only answering. If it is unknown, locate it. First name it. A, B, C, D, E over. I will call the point as F. Today, there is no space to write, so I am dictating now. Location of point between C and D where SF is 0. No, some more statements are there. I am dictating. Let that point be F. You should write there. At any distance. At X from here. At X from here. If that is X, this will be 3 minus X later. Now, this point you have to locate. You can, I told last time, in future, this I will not tell. I told 3 options for you. First option, shear force here equal to 26.4 is the shear force just to right of C minus 12 into X equal to 0, you get X. Or 26.4 divided by X equal to 9.6 divided by 3 minus X. You get the value of X. Or use that mathematical concept I told in class number 2 to get the value of X. X will come 2.2 meter. 2.2 meter. Go back and enter. Enter it. Equal to 2.2 meter. You should enter it. Enter. Okay. Enter this value also. 0.8 meter. Okay. Now, SFD is fully ready. Now go for bending moment diagram. For that, you have to go for BM calculation. I will remove this one and go for BM calculation. Today I will write earlier. Why? How many times I already explained, you are knowing it. So I will write earlier, then explain. We are ready for BMD. See, BM at A, 0. BM at C, plus 122.4 into 3 minus 12 into 3 into 3 by 2. I wrote their answer. BM at D, look this side. Which side is easier for you? Plus 129.6 into 4 minus 90 into 2. Now, somebody who comes in between, he will tell, that side it was clockwise, you took plus. This side it was anti-clockwise, but still you took plus. Why? I will tell him, you take minus and do whatever you want. You take minus and do whatever you want. I cannot repair such people. Those who have no patience, no dedication, I cannot repair. Shouted how many times earlier for sign convention, how many times I explained, people who go through thoroughly, they will be knowing. I should be harsh sometimes. This course, I will be more and more harsh in future. You follow, everything will be crystal clear. That's all. Okay, now, BM at E, 129.6 into 2 positive. BM at B, 0. Like some people, every class they will tell, see that sagging, hogging, sometimes some other method, smiling, etc. Some people still tell clockwise, anti-clockwise. They make very few classes. How much? Total 5-6 classes. I am going to make more than 150-200 classes. Complete coverage of SFD BMD. 150 guaranteed. So, therefore, those who are learning and interested in serious learning, they should follow right from beginning. Okay, now, lastly, also, note, also you already know it. After standard point, you also require BM at F. Okay, I will look this side. Plus 122.4 into 3 and another 2.2. 5.2 minus UDL of 12 into 5.2 into 5.2 by 2 minus 60 into 2.2. I got the answer. If you want, you can check from right side. See, you check it. Plus 129.6 into 2 plus 2, 4 plus another 0.8. 4.8 minus 90 into 2.8 minus 30 into 0.8 minus UDL of 12 into 0.8 into 0.8 by 2. But I will check the answer from one of the tricks. I know it. I do not require the location of the point to get maximum BM. I can only look there. That's all sufficient for me. But depending on PS point at D. I got 342.24. Yes, correct. Over. These all I will tell after the course is over, when I will tell much more finer points for those who are very serious about knowledge. Okay, now, lastly, note, you should write A to C parabola, C to D parabola. Don't tell the point F. F is a newcomer. But basically, variation is for standard point. A to C parabola, C to D parabola, D to E linear, E to B linear. You have to write it. Oh, sorry, forgot. Shear force you should write. I forgot today. A to C linear, C to D linear, constant. Why should I tell? It has been, I am telling all those things in past 10, 15, 20 classes regularly. Okay, now start. Plot the values. At C, 313.2, quite big. 313.2 here. And here, 338.4. See, not too much more, little more. This is called respect to mathematical part and subject also. Exact scale not required. See, slightly more. How much it is? 338.4. I will write here. 338.4. Here, 259.2. 259.2 means 338. 259.2 means another 70. Okay, reasonably okay. 259.2. And then somewhere here, see, this point where SFD crosses baseline, slightly more, 342.24. You cannot make out, slightly more. See, I'll put here. This is 342.24. Okay. Now, the last part, there is some power problem was there. I was explaining, suddenly power went off. So, I will adjust it there. Lastly, I told bending moment at F. That is the point where shear force diagram is crossing the baseline or zero shear force. See, answer. 3, this is the main purpose of this question is this point. 342.24, slightly more. How much more? Very slightly more. See? But actually, when you compare to 338, you cannot write. So, therefore, where here? See, slightly more. Yes, at least I got more. See here, 338, 313. Actually, 313 is lit. Okay, 313, 338, 342.4. Now, A to C parabola. E to B linear. E to D also linear. C to D, single parabola, it should keep on increasing. You see, from this side 86.4, that side shear force 26.4, so slope will be lesser. Here tangent will give more slope, it will become flat. See, slightly, it will come this way, reach the peak value, then drop back here. See, this is the point of maximum BM. If you draw tangent here, I draw once again now to make it more clear. See, this way, almost, it is almost flat. If you draw a tangent here, it should give a zero slope here. These all I thoroughly explained earlier, so you can make out. This is the bending moment diagram plus. So therefore, see parabola here. See, this is one parabola and this is single parabola. It will keep on increasing, reach a peak value, then slightly drop and come to 338. Then this will have more slope. Why? High shear force here. This is the bending moment diagram. Everything completed. Okay, now we'll meet in class number, I lost the count, 58 I think, where I am solving same question. I will change 30 kN to a higher load and explain to you what will happen. So it will be quite a short class, maybe 10-15 minutes, that's all. Then other class, I will go to some other type of load combination. Okay, thank you.